Today we're looking at part 2, the shortest path. So what we're trying to do here is get from one side of our diagram usually to the other side. Doesn't necessarily need to go to the other side. So on this one, it's not from X to C we're going to find the shortest path from X to Y. In order to do that, we need something to compare. So we need some numbers that we're going to put on our diagram in order to add things up. Now, as I said, these numbers can represent kilometres, they could represent minutes, they could represent money, they could represent any number of things. It's all dealt with the same way though. So our shortest path is always the shortest amount of whatever, the minimum amount of whatever to get from one place to another. We just don't use that word minimum. All right, so if we say that this is 12 whatevers, 16, 8, 6, 14, 20, 28, 18, 12, and 8. That means every one of those lengths takes up some amount of time. So what is going on here is that we have to try and figure out all those addings up. So method 1 is called trial and error. Now, even if you can see which one is the answer, you can't just write that one down. You have to show that it is less than other ones. So we would look for roots and add them up. So let's say our root is X, A, B, Y. How much does that add up to? So that's 12 plus 16. Oh, missed a number off there. Haven't got one here either. Let's make it 13. Plus 13. What is that? That is 41. All right, 41 whatevers, kilometres, paces, minutes, months. Who cares? All right. So if we were going that one, but that's our starting point. At the moment, our answer is 41. We're going to look for another one. So we could go from X to E to D to Y, which gives us 6 plus 20 plus 18, 38, 44. Okay, so now this one is still at the moment our shortest route. So we try another one. Let's go X to E to B to Y. That is 6 plus 14 plus 13. Gives us 27, 33. That's definitely our shortest one so far. And we would need to be absolutely sure that when we finish, we have decided that is our shortest one. So we've looked on it for the smallest numbers, all right? I've looked on here for whatever is the smallest amount. So I'm not going to go this way, 28, because it's going to be really hard to get to 33 with 28, so I'm not going to put him in. That 20 is also pretty big, so I'm not going to go that way. Might look at doing this way. So 12 plus 16 plus 8 plus 12 would be, let's do it, X to A to B to C to Y is 12 plus 16 plus 8 plus 12. That's 28 plus 20 is 48 miles off. All right, so on the trial and error way, I'm actually quite happy saying this is my shortest path. All right, our second method, method 2, is called Dijkstra's method, algorithm. Okay, what this does is it means that we actually travel multiple paths at the same time, adding up as we go. So when we're doing this one, we will actually put next to each of the letters a total that it takes, the smallest total that we've got that it takes to get to there. So if we're looking at this one, it takes 12. This way, 6 and 8 takes 14. So we're going to say this one, the shortest distance is 12. On this one, the shortest distance to get to E is most definitely 6. And we go through each point on our way to Y to see if we can find one that's shorter. So we're going to this point next. If we go this way, it's 28. If we go this way, it's 20. If we went this way, it's a huge amount. Don't even need to go there. All right, so I'm going to go with the shortest amount is 20 from E to B. Go back to D. Shortest way to get to D, 6 is definitely the shortest so far. Plus 20 is 26. 6 plus 14 is 20, plus that's 48. Where else could I go? I could go that way, but that doesn't seem to make any sense either. So 6 plus 20 is 26. All right, I'm trying to get to Y, but let's go to C first anyway. So 20 plus 8 is 28. That's most definitely the shortest way to get to C. But I'm aiming to get to Y. All right, from X to Y. So the last one is to find out what the shortest here is. So I've got 20 plus 13 is 33. 26 plus 18 is 44. 28 plus 12 is 40. Can't do anything else. So definitely this one is the fastest way. So that's 33. So I go backwards and I say, okay, this is my fastest way. That's how I got there. All right. So I would be showing that on my diagram and writing that from X to, well, made a move. Not that one. It's this one, isn't it? 6 plus 14. All right. Is X to E to B to Y, which again is 6 plus 14 plus 13 is 33. All right, so that one, you're showing you're working on your diagram. All right, the last method, method 3, is using trees. So what we do is we start with a tree. I'm going to go downwards because it's, oh no, I'll go crosswards. So that's X. Where can X go to? It can go to A. It can go to E. It can't go anywhere else. At this point, it is 12 and 6. All right? So because 12 is already bigger than 6, I'm going to go from 6. Okay? So that was my first branch. This one was bigger than this one, so I'm going to work on E until I go past A. So from E, I've got a choice of going to A, B, or D. Right? So from E, I've got a choice of going to A, B, or D. To get to A from E is 6 plus 14 is 20. To get to B is 6 plus 8 is 14. To get to B is 6 plus 14 is 20. To get to D is 6 plus 20 is 26. All right? So, this one took 14, this time took 12. I now need to revisit this one and see what happens from here. So I can go to B from here, and to B, it takes 12 plus the 16 is 20. Can you see that I'm actually getting the same numbers that I got on Djikstra, but I'm just getting in it a different way. All right, looking good at the moment. So still liking this option here because it's the littlest at the moment. So from B to get to Y, I can go straight there or I can go round the bend. All right, so I can go to Y or I can go to C and then to Y. So if I go straight to Y, I get 20 plus 12 is 28, that should be. 28, all right? 12 plus 16 is 28. So I can get 28 plus 13 is 41. To do it this way, to get to C, I've got 28 plus 8 is 36 plus 12 is 48. All right? This one, I've got to A, I'm adding 16. These are at the end, so I'm adding 16 here to get to B. So that's 30. It's already more than that one. I don't need to go any further because B's still got the same choices as this one. So that's a no-go. Right? That's a no-go. So far we've got 41 as our goal. From B, how to get from B to Y? Straight there is worth 13, so that's 33. So that one's now not a go, because I'm at Y. Can have a look at the others. Would I write them down? Probably not. So I could go that way again. All right, that way again. I'm not going to do that, because that's already too much. We know that this way is cheaper than that way. But I could go back to D and then come this way, but I can see that 20, to go through D to get there, is adding on from 20, 28, that's 48. Don't even need to go any further, because that also isn't a goal. So then we've got D, and D straight away, 2Y is plus 18, that's 30, 44, which is also not more than our answer, which is 33. So that's X to E to B to Y. So all of them gave the same answer. I'm not telling you one is better than another. It depends on how you like to go. So this trial and error might suit some of your brains. This Djikstra, drawing on the diagram and linking it up, might suit some people. Or you can do it by trees again.